This is USACO 2017 February contest silver. Why did the cow cross the road number 2? So this problem is a very basic prefix sum problem, and it's a very easy and nice problem to learn how to do prefix sums with. So let's get started. So the general problem is that there are some broken number of lights, so B broken lights. And in our sample test case, we are given that the broken lights are 2, 10, 1, 5, and 9. So these are the locations of the broken cows. And what we want to do is we want to find how many lights we have to repair until there are k consecutive or contiguous block of working signals. So the brute force solution for this would not work actually because the time complexity would be way too high. But instead, we can use a prefix sum solution in order to make the time complexity O of n for this problem. Let's see how we can do that. So I'm going to construct a prefix summary of broken lights. So let's see how that can work. Notice the indexes here are going to represent the number of broken lights, or the lights from 1 to n, where n is the index, okay? And the number of broken is just going to represent the number of broken ones, okay? So our test case, if I sorted, would be 1, 2, 5, 9, and 10. So let's take a look at how I made this into this prefix sum array. So for each of the broken lights, what I'm going to do is I'm going to add one onto the previous element. So how many broken lights are there from 1 to 1? So since 1 is broken, we need to have 1 as the index of 1. And from 1 to 2, we know that there are 2 broken lights. But notice from 1 to 3, so from light number 1 to 3, there still is only 2 broken lights because light number 3 isn't broken. So our elements are going to remain at 2 until we get to index number 5. Look at what happens at 5. So at 5, the number 5 is also broken. So the number of broken lights from 1 to 5 is going to be 3 as well. And let's take a look at index number 9. The number of broken lights from 1 through 9 is 4. So that therefore the number of broken ones is 4. Overall, the time complexity to construct a prefix summary is O of n in general, because all we're doing is we're going through n elements of that prefix summary and then constructing it. So after we have the prefix summary, how can we use it? So all we can do is simply just subtract numbers from our prefix sum. We're going to use a technique called the sliding window technique to do this. All I'm going to do is I'm going to take a look at k consecutive broken lights and see how many broken lights there are in the middle. So in our sample test case, k was equal to 6, I believe. All I'm going to do is I'm going to check, okay, how many broken lights are from light number 0 all the way to light number 6. So if I subtract 6 minus 0, or sorry, more clearly, array of 6 minus array of 0, what am I actually finding? I'm finding the number of broken lights from 1 to 6. Notice how this works. Array number 6 represents the number of broken lights from 1 to 6, and array number 0 represents the number of broken lights from 0 to 0, basically. Let's take a look at one other example on how we can use a prefix summary. Let's say I want to find array of 8 minus array of 2. This is going to be the number of broken lights from number 1 all the way to number 8. Let's take a look at why. So array of 8, as I defined in my prefix summary, represents the number of broken lights from 1 to 8. And array of 2 represents the number of broken lights from what? From 1 to 2. So all I'm going to be left with is, oops, actually I meant to say array of 3, is I'm going to be left with the number of broken lights from 3 to 8. Because I've removed the number of broken lights from 1 and 2. So all I'm going to have is 3, 4, blah, blah, all the way till 8. So I'm going to use this technique and see the minimum value of the difference between the two elements in the array. So let's see how we can do that. So notice that my sliding window here has a length of k. And all I'm going to do is I'm going to move it over once again. So from 1 to 7, I'm going to have 2 broken lights. Okay, so our minimum number of broken right now is equal to 2. And let's take a look at the number of broken lights from 2 to 8. How many broken lights will I have? Well, I'm going to have 3 minus 2, which is 1. So this is smaller, so our answer can be 1. So all I'm going to do is I'm going to delete it and replace it with 1. And then I'm going to see the number of broken lights from 3 to 9, which is 2. But 2 is greater than 1, so I skip over it. And then 2 to 10. Oh, and this should have been 5 instead. And the number of broken lights from number 3 all the way till number 10 would have been simply 3. So we know that since the minimum is 1, our answer is also going to be 1. So that's kind of the intuition behind this algorithm.